this is Sky recording live from the Twitch network. We're back. It's time for us to get this game engine rendering what we want. Yesterday we worked on getting a lot of our we got our injection settings kind of started. We've got our rendering stuff for Ka set up. Looks like we're getting close. There's one thing yesterday that I was talking about that I was really I'm pleased with was the 2D renderer, because we were tied directly to the graphics of Ka, and we couldn't get that library to connect up with the test framework with MUnit. So I don't like the idea of not being able to test that, and especially that it's kind of really core to what we're doing. So I'm going to try something here just to get this tested. I really want this tested. I promise that this is going to be a tested game engine, and I'm going to stick by that. So what I'm going to do is I'm going to uncomment all that stuff. And the one thing I was not really liking was that the graphics was dynamic, and that was the only way to get around it. So I'm going to try something like this. So I'm going to create a new file. And this should work, but we'll tweak it as we go. Apparently I can't create just a regular file here. So I'm going to do a mock graphics, mock Ka graphics. Do 2D graphics. And that's going to be a hex file. And so we're going to do package display, display dot to Ka. And this is actually just going to be an interface. Mock Ka to the graphics. Is that right? And I have, oh, doesn't even have public on it. Oh, that's embarrassing. Okay, so we have our mock 2D graphics. And so what we're going to do is we're going to mock out all the stuff we need for this to pass its tests. So let's look at our 2D renderer. Looks like we're going to have a draw subimage. So I'm going to trim a lot of this down. So we're going to say function that we have our image. We'll just call this dynamic. No, this won't work because of that image. Darn it. Thought I was going to be able to pull it. No, wait, because we're using a bitmap. Let's try it. Let's try it. It's only one way to find out. So our image, our x, which is going to be float, y, which is float, sx, float, sy, float, sw, float, sh, float, and that's a void. There we go. And what we're going to do is we're going to comment out all of this. Yes. We're going to do this TDD. Okay? And so we're going to go through here, and now our graphics is going to be our mock Ka graphics. It's going to be clever, I think. I'm going to mock our mock Ka graphics. Now this is where things are going to get interesting. So if we try and build this, it won't build. It shouldn't build. Let's try. hexlib run init test, and it doesn't. Well, for one, it's missing a semicolon. I don't know what line it was. 20. Quite weird. Yeah. Oh, because it's because we named it ka to be vendor. Make sure everything lines up. Oops. We need that. What's your problem? This is the class. Oh, that's it. Okay. So, type not found is the ka font. So we're going to comment that out for now. Those two. Anything that's ka related. Okay. Type not found, ka graphics. So what we're going to do is we're going to do public var graphics lock ka to the graphics. And what we're going to do is we're going to say, look at this up here, is if test, use that one, else. And so now we're putting a macro around this. Why that's being, oh, okay, that's fine, that's the editor. So we're going to put a macro around this to see if it'll actually compile in the other graphics. And so what we need to do, we need to add one more thing, is on our test, the HXML, we're going to say -d test. And let's see, missing cost right, missing super. And ka2d render test line 20 requires a container. PRV container sprite. That's fine. Okay, and then container equals new sprite container dot init copy to container. And there we go. We actually can test this now. So that's what I expected. So we should be able to run the other build, and that should build as well. And it does. Okay, so now we can get around to actually testing this. I suspected this was going to work this morning, but it is definitely going to happen. So it's not my favorite solution, but it is a solution. I can put this in test. I can put this here. We can actually change this to ka font, like so. Like I said, not my favorite solution, but it'll work. I'll have to abstract this guy out. I'll have to abstract this guy out, and we'll have it done. So what I'm going to do is I'm going to delete these two. This font, so I need to make a new file mock font, mock font, .x. And just gonna take a page out of this book. Mock font, and we'll do with that. Okay. And then last thing we'll have is mock color. And it might seem a little excessive to do this, but this is kind of the nature of the beast. When you're dealing with, sometimes you have to do this with testing. Actually, it's this one. Sometimes you just have to kind of rough things in and make sure they happen so that you can test them, because the testing is more important. And as long as we keep our things that is simple as possible with our interaction. Why is that not resolving? I'll just let it do its thing. It's important to have these tests in, and so it's important to me to be able to test these things, especially the renderer, because those simple now, relatively simple now, could get complicated later. And so I want to make sure that we can test this stuff. So now the font is in there. So I'm going to kind of defer this for now. We'll be able to test this. I might even test this offline, just so we can move forward, but this is how we're going to test it. And same with the color, we just have to create a we'll just have to create a static variable, which will be probably better anyways than trying to get this every time and then getting this every time. And just create or just a private inline function, and that'll do the job as well. So we can actually do that right now. Just say private inline function get color from value is a uint, going to return a color, and this is where we're going to override things as well. So it's going to return the color, and this is going to return color. Oops. Come on. Return color dot from value. Color from value. Okay. And now we can get color from value. We don't actually lose any performance out of that because we actually have this as an inline. And so if test, oops, that's not right, fantastic. If test, and keep this line, else, and, oops, and okay, there we go. So now we can just do return. This is going to be a mock color. So now we're just going to return null until we test it. And there we have it. Now we're testable in this class. Like I said, it's not the cleanest, not my favorite, but I'd rather have it tested than not. So I'm just going to make sure the tests still run. Let's see here. So I think these things seem to be missing some pieces that I did not see before. Probably because they're being used now. var. That one's fine. Clean up some of the build errors. Commander display should have to be 933. Let's do this at display node. Container. Yes. Display node container. Okay. I guess it needs to do this. Okay. Line 41. Oh, that's the Mach 2 graphics. Okay, so we're going to do the var font size unit var font color unit var font name string var text string. Alright, we're getting this all locked in now. Let's just color. Or mock color. Getting close. No field font, so font is going to be here. Mock font. And draw string. So function draw string. This doesn't exist. Text string x float y float. Not to character type required for external possible integers. Oh, okay, so let's return void. There we go. It's our test build. There we go. So we're going to come back and test these. I want to get moving on with what I was doing yesterday with getting some of this rendered on the screen. And we're just going to do a little bit of a playground stuff that we're going to remove later, but we just want to see things rendering. So here we are, we're back to our injection settings. We passed in our frame buffer, which I don't think we'll need, so I'm going to take that out. And as we saw yesterday, this was actually being assigned, so I'm just going to put that there. And in our injection settings, we're going to remove our frame buffer like that. And just want to make sure everything's casting correctly. Okay, good. So now we have, there's one thing I did think about last night is I don't like this idea of having a renderer here. for our interface. Probably going to take that out. We're going to do something probably better with that, but I think I'm just going to stick with it for now, just so we can kind of move forward. I really want to get something rendering on screen today with our new container systems. So what I'm going to do is I'm going to create a layer manager. This is going to be a renderable layer manager. I'm going to use the object factory, because now that we have that created, we're always going to use it. For instance, layer manager. And layer manager requires a construction argument as a top level container. Var sprite, get that container. Sprite object factory, create instance, sprite. And so we're going to pass the container in, and then we'll need a renderer. This is going to be a ka2d renderer, object factory, the instance, ka2d renderer, and I believe that also has, yes, the construction argument. Container. So now we're going to say layer manager. We're going to need another container, which is this. So this is just the construction of the layer manager. In fact, we probably move this down here. Like that. Move that here. Add layer by name, and we're just going to call this the bottom. We're going to create more meaningful names later. Don't worry. We're just kind of roughing this in, making sure that what we have is working. And our renderer. Okay. And now, I think I have what I want. I'm going to take this injector. Okay. Just thinking through. Okay, so now what I'm going to do is I'm going to define the rendering pieces we're going to use. Oh, we need to actually assign the injector map value. Whenever we request a layer manager, we're going to return the layer manager. There we go. And we're also going to map. Let's see here. We want to map class. So when we're asked for a bitmap node, we're going to return a ka bitmap node. And when we're asked for a display node container, we're going to return a ka sprite. When we ask for a text field node, we're going to return a ka text field node. Okay? And so that should get us there. The only thing we don't have set yet is our font. So here we're going to say ka text field node fonts. It's not public. Oh, it's our renderer. 2D renderer fonts is going to be our fonts. So we have our fonts ready. We're mapping out our classes. I think this should get us most of the way there. And finally, we're going to do object factory, create instance. I'm going to create a factory here. We're going to call it scenes playground. And we're just going to call this our playground. Now we've got our playground. One more thing is I want to define the top level renderer. So I think I will need this, a separate one of these. This is what I was thinking about changing anyways. So we're going to go down here. No. Definitely want it up here. Injector, map value, renderer, renderer. Okay, so now when we ask for the renderer, we're going to get a car renderer. We've got our top level. I think this should be what we need. So now we're going to instantiate the playground. And I think our hard stuff is behind us. So now, this class here, just so you understand, some checkpoint settings, is going to be significant to every game you make. This is not specific to the game engine. This is going to be your game specific settings. And we'll extract some of these out and make a game engine, probably GitHub, and then we're going to probably make our game GitHub. So one more thing we need to do is we need to inject our back buffer as our graphics. There's no real nice place to put this. We'll put it here. Injector map value when asked for graphics to graphics. We're going to give it the back buffer G2. So how this is going to work is in our 2D renderer, we've got our graphics injection. In fact, I want to space this just a hair. I'm just going to stick this right here. Like that. It's a bit clearer, I think. So whenever we ask for our graphics, it's going to actually go in and inject the one from our injection settings here. And now we can just work with our one graphics. Let's continue on. So we have got our playground. I'm just going to inject our object creator. And I'm going to inject our layer manager. There we go. Playground is going to implement base object. There we go. And so we know that init will be called implicitly, so we can have our fun here. Back to our live game. I'm actually going to clip out. I don't want our update to happen until everything is running. So I'm going to actually take the schedule out and put it here. So now update gets called now. I'm going to take this, pop it down here. No. there. So we have our rendering loop, which will abstract too, don't worry about it. And then I want to assign this to our settings. Settings dot and I'm going to change this to public. Just because we need access to it, which we do right now. Injector, inject into this, period. So now this is going to run through our injector. With that, we can now inject our renderer. Okay. And now here, we get to turn this all back on. And we can turn this on. And cut that. Renderer. Dot render. There we go. That should do it. And I think just simplified. No, I did not. So actually going to change our renderer. This is the thing I wanted to change. In fact, I'm going to change it later, or sooner than later, but here we're going to map our value to our layer manager. And as you know, that this doesn't implement render yet. So here, implements render. I'm going to take this out, so I'm not going to need to test this, because I just want this in for temporarily speaking. So now we're going to do for layer and layer map. Layer renderer dot render. So we're going to eventually take the renderer out. I don't like the idea of it. So I'm just going to go ahead and run a build on this to make sure we don't have any build errors yet. We've got one error, which is unknown identifier layer manager on line 28. Oh, I just need to make this a renderable layer manager. Okay. So everything's compiling. I'm going to go to our playground and I'm going to create a grumpy cat. Actually, you know what we're going to do? We're going to do something a bit more clever. We're going to use that async. I'm going to say render show playground. Playground. Function. Game still works. Nope. Void. And now we can do catch async. Okay. Have a function. Show playground. We're going to create a bitmap. What was called the grumpy cat. Grumpy cat. This is going to be a display node equals object creator. The instance. Actually, it's not going to be display node. This is going to be. It's going to be a bitmap node. The instance bitmap node to set up bitmap node for us. So now our view is very abstract. This is the point. I'm also going to need our bottom layer. This is going to be a display node container. And then talk to our layer manager, get layer by name, bottom. You can see how this is coming together, I hope. Bottom. Now, with our Grumpy Cat, we've got to fill in our pieces. So Grumpy Cat, our image data is going to await the loading of load image, Grumpy Cat. Nope. There we go. Grumpy Cat. I think one thing we need to do with our bitmap node is when our width and height are set, we're going to default the height to that. Okay, width, and our height. We'll be able to override that later, but that's just for now. So we're going to say our SX is going to be 0, SY is going to be 0, so we're going to do that. Our width is going to be 800, 600, and our bottom layer, add child, Grumpy Cat. Now, if everything is hooked up in builds, does it? Can't just, no. Go away. And go run. Get layer by name. Should be coming together here. This is the exciting part, waiting for it to build. No, actually getting things rendered with all of our effort in place. And it broke. So, and I see it right there. Grump Cat note. Hopefully that's what the problem is. I did find a way to debug this where C++ will just crash, which is a bummer. I might be able to wrap that in a try-catch, very top level. Or what I've done is actually ran it in Flash, and Flash will kick out a much better error message. And that one crashed too. So let's do the Flash. At xlib run Flash. Open build Flash web. And can't read properly of no object reference on the car render sometime. Here. Yeah, null someplace in here. So render children. I wonder if in settings. Put a couple trace statements in here. Trace graphics, trace bitmap, trace bitmap dot image data. So our graphics is null, which I kind of suspected. So I think it's because our 2D render was instantiated. Yep, absolutely. Sit that there. That should do the trick. And so it's not crashing. Here. Hopefully see a grumpy cat. There it is. There's our grumpy cat. So our rendering is hooked up. So now let's play a little bit more real quick, just to see that all of our pieces are as expected. So I'm going to create a middle layer. I'm going to create a top layer. This is the middle, top, and then our layer manager, based on our documentation, says if we add a new layer, it should add it on top. So if we do this in order, like that, we'll have 3 layers. So now I'm going to create a wizard, bitmap node, hit creator, create state instance, bitmap node, wizard, image data effectively, and then do something slightly different on this one. Image, I'm going to load the image here, image, and here is the image. Real width, image, real height. Image equals await assets, load image. I think it's just wizard. Image. And with this async loading, it does make this a lot more convenient. I hope you agree. Wizard dash sx equals 0. Wizard xy equals 0. Wizard sw equals image dash real width wizard as h equals image real height. Okay, so we got that into place. We're going to add them to the middle layer. Add child wizard. And just to make sure everything is working as we think it is, we get one more, which is hello. Text field node equals object creator, create instance, text field node. There we have it. Our hello text is going to be hello world, hello font name is going to be this word I don't like to type, so I'm going to copy it. There we go. Hello font size is going to be 32. Hello font color will be color, put that, from value, no, I think I'll just do image. Okay, top layer, add child, hello. Here we go. Build, build, build. So we should see 3 things rendered on screen if things are set up correctly. 3 things. And if we look, we only see 1. And I know it's wrong, and I did this on purpose as well. You might think I'm a jerk, but I think I can live with that. So I'm actually going to take out the bottom layer, and I'm going to run this again, and you'll see, hopefully you'll see hopefully you'll see something different. If not, I'm really bad at rendering 3 things. And if you look here, here's our wizard with the hello world. So it's like rendering in the wrong order. And so the reason for that, like I said, I did that on purpose. Just so, this is the reason why I didn't like this in the first place, is that we're actually using a map. And a map, and we're just iterating through the map values. The map, we can't guarantee the order. And this is one of the reasons why I don't like this. So in order just to fix this for now, let's create renderers. I'm going to create a array of renderers. And this is array of renderer. And we're going to change this. I don't like this approach. But I just want to get this on screen for you so that we can keep playing with our stuff. And I can kind of show you kind of a special way this can happen as well. This can be kind of fun. Renderers, we're going to push our renderer, and then down here for render so let me just clear that up a little bit. And unexpected that bracket 18. How about that? There we go. As promised. They are being rendered in the correct order. I don't know if you can see the hello world is real faint, so we're going to change that to blue. Change that to blue, so this should be 1, 2, 3, 4. Change that to blue. And let it build. Build, build, build. And as you see, it's all blue. So that's not an accident, because if you look back here at my text field node, oh, not the text field node, the 2D renderer, I had told you I was going to set this back to white, and this is why. If you don't set it back to white, it'll carry across the entire buffer. So that won't build because I didn't come to that. Our tests are now broken. But we'll fix the tests. Come on. And there we go. There's our hello world. So our layers are working correctly on our layer manager. I can only assume that the containers are working correctly, but well, I know they're working correctly, but we're just going to do one more thing with our playground just for fun's sake. We're going to take this and change this to 64. So now we're just going to show one wizard. We're going to dupe this whole thing here. And we're going to set this to 128, I guess. 128. So we're just going to grab a kind of a random wizard at, oops, no, don't be trapped. Random wizard at 128 by 128, which is probably somewhere here, I think. Just like a quick cursory glance. So now we're going to, we don't need to reload our image, so that's the plus on that. And this wizard should show up on the other wizard, and we just want to move him to the side just a hair. Send him over, looks like 20 pixels. So if everything works right, the hello world should still be on top. In fact, I'm going to prove this slightly better, I guess. First of all, that won't build, so let's cancel that. I'm going to put this here after the top layer. Not that it exactly matters, but because we are talking to a different container, but this does prove something. This is why this won't build, because we declared this. So now, this other movement wizard should be on top of the other wizard. Everything is set up correctly. Last building, talk to you guys. I encourage you guys to visit with me. It'd be kind of nice to get some live interaction. And there they are. And you can see, hopefully you can see me zoom in here. You'll see that one of them is stacked on the other one. So the layering is working. That's exciting. That's exactly what I wanted. So we've got a bit of a playground here going on. We've got the injection settings. I know I covered a lot with this injection settings. It could be kind of intimidating if you're not used to using dependency injection in this way with metadata. We made some changes. We did some unit testing. So I'm going to call this good for today. So I'm going to add to our sources, status, to add to our test so we can test that later. Git add test that. Oops, git status. So there's that. We say git commit. Added a playground with visually proving our layer manager is working. Okay, git push Skylar master, git tag with today, which is 2016-03-08 at 8:31. Message injection settings with layer manager, push Skylar our tag. We should be able to go to our GitHub account, live game, and hopefully our tag is here. There it is. We're essentially, not essentially, we're actually up on GitHub with our cat. We should be able to run it. If not, let me know. I'm very interested if you guys are having issues or if you're learning anything, if you've got any questions about anything. I'm ready to answer them. I really want to answer them. I want you guys to understand this is the core, the real core of what's happening with our game engine is this dependency injection and our rendering engine and how we can swap out different rendering engines. So sort of to kind of go back and iterate on this, if we look at our injection settings, we're mapping our bitmap node and our cost sprite and our text field node to these interfaces. They're very abstract. They sort of define some very simplistic things. And so if we took our game engine out of this project, which I think I'm kind of considering it well, we can implement an OpenFL two-dimensional display. We can do a heaps two-dimensional display. We can do an enemy two-dimensional display. And now we're not tied to our rendering engine anymore. And whatever rendering engine is your fancy, you can go ahead and implement it. You can do a pull request on GitHub. I'll merge it in, and there's no reason why this engine can't support all rendering types. And we're going to do the same thing with audio, and we're going to do the same thing with input. So that's how things are going to happen. Hope you guys learned a bit. Come back again tomorrow, and please subscribe to my YouTube channel. It's YouTube/SkylarCarr. And I hope to see you guys soon. All right, have a good one.